If your agent only works when the model behaves perfectly, the problem is the contract. I'll build the same flow with PydanticAI, so tool inputs, outputs, and retries stay enforced. This is the workflow you'll know how to run when we're done, which answers a question using typed tools with retries and returns a validated result. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Agents get messy when outputs wander. You ask for a number, but get prose. Or the model calls a tool with bad arguments. In production, those errors cost time and confidence. PydanticAI Typed Agents solve that by making the contract explicit. Success looks like a short, validated result every time. When the model drifts, you detect it and retry automatically instead of shipping bad data. At a high level, typed agents mean two things. First, you describe the shape of the result with a Pydantic model. Second, any tool the agent can call also has a typed signature. The agent then treats the model output and tool inputs as enforceable contracts, not suggestions. You get deterministic parsing and clearer failures. The trade-off is that strictness can add retries and latency, but you gain reliability. We will build a small pipeline that asks a model to pick and verify a choice using a typed tool for prices. It matters because many decision tasks need exact numeric outputs. We will show the agent returning a typed title and a word count, then adding a typed add tool, then ranking items from a catalog, then enforcing a validation guard with retries, and finally measuring calls and latency, so you see where time is spent before the final validated answer. Now we'll create the minimal validated agent. This snippet creates a minimal PydanticAI agent that returns a validated Pydantic model. The out class defines the structured shape we expect, a short title and a word count. Agent wires an OpenAIChatModel to the schema via the result type argument, so generations must conform or be rejected. The call to agent.run sends a compact instruction asking for a 3-word title and a count of a small phrase. The library parses the model response into out, exposing a data attribute with typed fields. If the model drifts, parsing fails instead of silently returning junk. The printed values confirm a proper schema match and a concrete word count. Next, we'll add a typed tool to keep arguments strict. This example adds a typed tool to the same PydanticAI agent to keep arguments and outputs strict. The calc model defines a tiny contract, an operation label, and an integer value. The add function is decorated with @tool and uses runContext plus annotated A and B integers, so the agent must call it with valid types. The agent now includes tools equals add and a calc result type, pushing the model to invoke the function and then shape its final reply into calc. Calling agent.run requests one addition and a schema labels. If you change the numbers, value updates deterministically via the tool. The printed fields show the tool's computed sum and the declared operation. Next, we'll show using a pricing tool to pick the cheapest option. This code asks the PydanticAI agent to rank options by calling a typed pricing tool and returning a structured decision. The catalog dictionary holds stable test data for 3 items. The getPrice tool exposes a single argument, name, and returns a float pulled from the catalog. The agent is reconfigured with tools getPrice and a pick result type comprising a chosen name and a price. The agent.run instruction tells the model to call getPrice for each candidate and select the cheapest. If you adjust catalog values, The selected item and returned price change accordingly. The printed result shows which option won and the exact lowest price. Next, we'll harden the agent with validation and retries. This snippet hardens the agent using Pydantic validation and built-in retries in PydanticAI. Guarded pick adds a model validator that rejects any output whose price is not the minimum from the shared catalog dictionary. The agent is configured with max output retries equals 2. So, if the model first returns an invalid schema instance, PydanticAI will automatically re-ask for a corrected result. The getPrice tool remains the single source of truth, and the model must align its final structured reply with guarded pick. Increasing max output retries improves recovery from schema drift at the cost of latency. Reducing it speeds responses, but risks invalid outputs. The printed status confirms the output passed validation and shows the guarded price. Next, we'll add simple monitoring for tool usage and latency. This example adds pragmatic monitoring around the same PydanticAI agent for incident-style debugging. A small calls list instruments the getPrice tool to record each invocation, giving a precise count of tool usage per run. The agent continues to enforce guarded pick for structured outputs, keeping responses safe. The code uses time perf counter to measure end-to-end latency around agent.run, converting the result to milliseconds for easy reading. If you expand the task or increase retries, latency will rise and the call count may change, revealing where time goes. The printed values show both runtime and how many tool invocations occurred. Mapping this toy example to a real system is straightforward. Replace the small catalog with your product feed. Keep the typed price tool as the single truth source. Use the same guarded model to ensure your pipeline never returns a declared price that does not match the source of truth. Recap. First, PydanticAI typed agents make result shapes and tool arguments explicit, so you get typed outputs. Second, use this when you need reliable numeric or labeled outputs from an agent that may otherwise drift. Third, a caveat. Stricter validation adds retries and latency, so test the trade-offs. For the next step, scale and evaluate this exact approach on a larger catalog and measure latency and tool call counts to find performance bottlenecks. If practical AI engineering helps, subscribe and watch the AI engineering videos.